Okay, so how do we rewrite circle equation using completing the square when the equation is presented in this form? That is our next example. I'm going to keep your steps description on the right side, and as we go through, I will highlight the step that we are up to. So, completing the square is used not only for solving quadratic equations, but for rewriting equations of circles in a center and radius form. Let's observe our equation just to understand it better. You will then notice that there are two terms that contain x, two terms that contain y, and one constant. The other side of the equation is 0, but technically you can have another numeral here. So let's prepare the terms. Let's group the x terms and leave some space for the third term of x, and then regroup the y terms and leave some space if needed for the third term that we will try to identify. I will rewrite x squared 10x and leave some space, and then y squared positive, just like an arrow, minus 8y, and I will leave some space. I will then verify that coefficients of x squared and y squared are positive 1, which is our case. If they were not, then we would have to divide every term of the given equation by that coefficient that we would need to get rid of. So now I will complete the 0, and no, I did not lose the 35. It's just that I will now isolate it. To isolate positive 32, I will need to subtract, of course, subtract it from both sides. So then in the equation below, I should write minus 32. And now I can focus on completing the square. First for the x's and then for the y's. So step number 5. I am noticing the plus here, so I will be going for square of the sum. But either way, I will need to identify that b. So I will use a second term to figure out who that b was. I have positive 10x, which means that what hides there is a positive 2 multiplied by x and multiplied by 5. So that means that my b is 5, which means that b squared should be 25. So I will want the third term that right now is missing to be a positive 25. So I'm going to add it right now to the left side. But then, of course, to keep my equation balanced, I would have to add it to the other side as well. This will allow me to rewrite the trinomial for x as a square of the sum where my variable is x and second term of the binomial is 5. Now I can focus on work with the y. So y also has two terms, and I will need to identify the third term. I'm noticing that I have minus 8y. So it's actually a situation of a square of the difference. Still, to identify my b, I will need to recover another factor that's hidden in this term. I know I have minus 2, I have the y, but then it had to be the 4. So b in that case would be 4, and b squared would be, of course, 16, the square of the 4. This means that since I wish for the third term to be 16, I can artificially add that 16, but I would have to do that to the other side as well. I now will be able to fold my expression for the y into a square of the difference. So this plus right here will be between my two binomials. I am preparing for my square of the difference. The variable would be the y, and b was the 4. I now will have to figure out the simplified term for the right side. That you could check with a calculator, and I'm sure you will agree with me that the result is 9. This is it. You just rewrote your original equation of a circle in the form center and radius. From this form, we can identify the coordinates of the center. Remember what they would be? They would be a negated value of positive 5 and negated value of negative 4. The radius of this circle would actually equal to square root of 9, positive square root because we're looking for the length. So since radius squared according to the formula of a circle is 9, then as I mentioned earlier, the positive square root of it would be the radius itself. And these are the two main characteristics of your circle. So if you were to plot it, we can make a little scheme, a diagram for it. 5, 4 for the center. You would find the radius of 3, and that would be your circle right here. And that's the end.